So in this lecture, we will understand what deep learning is. Okay. So fundamentally, whenever you go and read any deep learning book, you'll find this complicated image they start with, and then there will be codes and everything else. In this lecture, what we will do is we will try to break this whole image down into small segments, and we will try to understand deep learning in a deeper way. Okay. So we will do the required mathematics where it is required. I will try to keep it simple. And if you don't understand, you can ask. So fundamentally, what are you trying to do? So fundamentally, you have what is called as a data set. Okay. So let us bring one data set. So let's use this simple data set that has this hours and scores in it. Okay. And let's pick up a small segment of this data set. Fundamentally, this is like 24 data points. So we are just taking a small one. Okay, so this is our data set. Now, what is this data set, and what we are trying to understand from this data set? Well, this data set has two things. One is the hours, which is an input, or you can call it as an input feature. So each column which acts as an input, you call it as input feature. As you can see here, there is one input, so I can write that this data set has only one input feature. Okay. Now the scores here is the target, or you can say you want the desired, it is your desired output. Okay. So people also call it target or target feature. Anyways, so now, so there are some group of students whose data has been taken, and they maybe they're asked, okay, how many hours do you study each day, for example, and then whatever exams they give, they look at the scores, and thus they have made a data set where you have input hours, where many students who are studying how many hours per day, it is there in each row. So for example, here you can see 9 row. So this is a data set of 9 students, but we have taken only snapshot of it. Fundamentally, the data set is of 24 students. Okay. Now, what you want to do? Basically, you want to predict. So, uh, suddenly, if I give you a number of, say, some 28th student, so this is a new student, and he studies, for example, there is a data which is 5.1, so let's make it 5.9. And the question is, what is the score that he is going to get? This is what you want. Towards the end, you want to predict something. Now, in order to predict something, what you try to do is, whatever data you have, you try to fit a curve f of x for the data. Now, this hat here means that you are trying to fit an approximate curve that fits the data. Or you can say that you're trying to find an approximate curve which is very close to the true curve f of x. Now, what do I mean by approximate curve and true curve? Well, you see, uh, when you do a graph, so for example, let me make a graph. So this is like, say, the hours in the x-axis. So x is the input, and you have scores in the y-axis. So f of x is the output, and your data is something like this, some random spots here and there. What you want is that you want to find a curve which best explains this data. Here it seems like a straight line kind of best explains the data. So this is, like an approximate curve that explains your data. Then how do you understand true curve? Well, in this case, true f of x, finding true f of x will be difficult or maybe impossible. So this is your thinking exercise. So in this case, can we have a true f of x? True f of x means one function that predicts whatever value, whatever input you give, and the prediction is 100% correct. So this is what we mean by true f of x. So does this exist for this data? Well, if you think a little bit, and this is where domain knowledge comes in. So you have to understand what the scores and all these things. Some domain knowledge is required, and my guess will be that true f of x in this case is very difficult or impossible to have, and we can discuss it later on. Okay, now we are doing deep learning, so we need to dive into that. Anyways, so now you want an approximate f of x which helps you in predicting for a given particular hour what is the score a student may get, a new student who has come into the school. Now this is, you might have studied in the name of linear regression. Linear regression. So linear regression usually you try to do when you have data that kind of follows a linear line. Okay, so this is just an one dimensional so it has just one dimensional, one input, so I call it one dimensional input feature, and one target. Okay, if the input feature is larger, I mean, if there are 3, 4, 5 input features, say even two input feature, then what we do is multilinear regression. We'll not get into that as of now. Okay, so linear regression is like telling you, okay, I'm giving you one uh, function which best describes your data. Now what deep learning does here for you? Deep learning comes here and tells you, okay, I can do the same work for you, but in a much more robust and complicated way, and maybe my result will be better than linear regression. So this is where deep learning comes in. It promises you something better, and it does this the whole process in a more complicated way than a normal linear regression or whatever we have studied does it. Okay. So deep learning consists of the following. It has what you call as neurons. So the word neurons is kind of like taken from biology, where our human brain has neurons and they function and the way we see and understand the data. So this is also an artificial intelligence sitting in our head. Now, though inspired from the brain functioning, uh, the deep learning does not exactly mimic the brain functioning. Okay, it has a nice mathematics inside it, but it cannot be the exact mimic of a brain function, the way the whole neuron functions. Anyways, so let's try to understand deep learning, and we will understand deep learning like this. So we will make it much simpler. How do we do that? We will take only one input, we will take one neuron, and we will try to predict an output. So drop it to that simple level. Okay. Now, before we move on, let me tell you that this whole set that you see, which contains 1, 2, 3, 5 neurons, so this is a layer. So this you can say is the first layer. Similarly, this one is the second layer, and similarly you have a third layer here. Okay. So this one here is the input layer where you actually give input, and this one here is the output layer where you actually get your output. Okay. My question is, can we do deep learning using this simple data set? Why not? Let's give it a try. So if we try to understand this data set from the context of deep learning, then you see you have only one input feature. So your input layer will have only one circle. So your input layer for this data set. So let me write it like this. Simplified deep learning. So we start with one neuron. I'll give you the definition of one neuron, and then we will go much deeper into the whole deep learning context. So ours is our input. So we have just one circle that depicts that there is one input. Now what we will do is we will play the whole game using one neuron, as I said earlier. Now what is this neuron? What does it contain? That I will explain. But right now, each circle that I'm making here between the input and the output is the neuron. So we have one layer. So fundamentally, if you can see, we have, I'm taking one layer and I'm taking one neuron in that layer. So this is for simplification. Okay. And then I have an output layer. So this is my input and this is my output. Okay. Now, uh, let us go and understand this in a complicated mathematical definition, and we will break it down slowly. So let us define one neuron. Okay. So once we understand what is the definition of one neuron and then we break it down, then we will have an understanding of further neurons.